In this lecture, we'll learn about real constants and rule for constructing them. In the previous lecture, we have learned about integer constants and how to construct them. The link of that video is given in the description box. Real constants are often called as floating point constants. The real constants could be written in two forms. The first form is fractional form and second form is exponential form. So we'll be starting with the rules for constructing real constants that are expressed in the fractional form. The first rule is a real constant must have at least one digit. Second one, it must have a decimal point. So in the concept of integer constants, we have already seen that an integer constant cannot have a decimal point. Whereas when we're talking about floating point constants or real constants, they must have a decimal point. It could be either positive or negative. So from the examples, we can see few of the values are declared as positive and few of them are declared as negative. When no sign is provided, by default, it will be positive. No commas or blanks are allowed within the real constants. And here are a few examples. The second form is exponential form. It is usually used if the value of the constant is either too small or too large. In exponential form, the real constant is represented in two parts. The part appearing before e is called mantissa, whereas the part following e is called as exponent. So this is the example. The part which is appearing before e is called as mantissa. So 6.95 is the mantissa here, whereas the portion which appears after e is called as exponent. So -4 is the value of an exponent. Now let's see the rules for constructing real constants that are expressed in the exponential form. The first rule is the mantissa part and the exponential part should be separated by a small letter e or a capital letter E. So here in the examples, we can clearly see that the mantissa part may have a positive or negative sign. When no sign is provided, default sign for mantissa is going to be positive. The exponent must have at least one digit, which must be a positive or negative integer. If no sign will be given, default sign is going to be positive. And finally, the range of real constant expressed in the exponential format is this. Then we have few examples of real constants which are expressed in the exponential form. Let's see a C program to understand how to define real constants. I'll be starting my program with a comment. Once we are done with the comment, we can provide the preprocessor directive, which is #include stdio.h. So #include is a preprocessor directive, which is including standard input-output header file. For that, we can provide the declaration for main function. So main is the name of my function, int is a return type. Here I'm starting the main function by providing the open curly brace and closing it by providing the closing curly brace. As a return type for the main function is int, we have to terminate it by providing return 0 statement. Now here we can define the real constant. There are two ways with which we can define them. The first one is by making use of const keyword. So const float r is equal to 7.856. Const is a keyword over here. Float is the data type. R is the name of the real constant. This is called as an assignment operator. 7.856 is the value which we are assigning to float or real constant R. Now on the next line, let's just try to print the value of R. For printing the value, we are having printf function. So inside printf function, within double quotes, first of all, we have to provide the format string. For real constant, we have to make use of %f as a format string. Then comes comma and the name of my real constant, that is R. And then here we can terminate the printf function by providing a semicolon. Now let's save the program. For that, I have to go to File and Save option. I can give the file name, and here I can provide the extension, that is .c. So this is the name of my program. .c indicates it's a C program file. Once we save the program, we can go to execute for compiling the code. As we can see here, there are no errors, no warnings. I can go to execute option and run the code. So this is the value of R. Let's try to make this printf message interactive. So I will say after making the changes, every time we have to save the code. Again, I can compile and run. And we can see here, we're getting the same value. It's just preceded with this message. As we've already seen, when we are talking about the constants, their values cannot be changed. Let's try to change the value of this constant and see how it behaves. So I will say R equal to 2.3567. So this is a new value which I'm trying to assign to this real constant. And on the next line, I'll print it. Here comes the format string with %f, and then I can provide the name of my real constant. As we have made the changes, we have to save the program. Control S is a shortcut key. I can go to execute and compile the code, and here we can see the error. So assignment of read-only variable R, it simply says that R is the read-only variable, which is nothing but a constant, to which we are trying to reassign the value, which is not possible. To allow the normal execution of this code, I have to delete this statement. Along with that, I can delete even this printf statement. Making these changes, we can save the code, go to execute option, compile and run together. As we can see here, there are no errors, no warnings, and we can see the output. In the same program, we'll see another way to define real constant, and the second way is by making use of define preprocessor directive. So for that, I have to say define the name of my real constant. Let's say it's pi, and next to it, I can give the value. This line, we can try to print the value of pi. So for that, printf function within double quotes, I can give a message. Here we are terminating the printf function. After making the changes, we can save the code, go to execute, and click on compile. No errors, no warnings. I can go to execute option again and run the code. So here we can see that the execution happens sequentially. The value for real constant R is something which is appearing first, and then next to it, the value of pi constant. As you can see here, these lines are coming together. To separate them, we can start my second printf function by using \n. So \n indicates new line. After making this change, I can again save this code compile it and run it. Now we can see these are two separate lines. So understand the use of \n. Whenever you want to start a new line, you can precede that line with \n within double quotes. So in this lecture, we have covered what are real constants, rules for constructing them, and how to define them in C programs. In the next lecture, we'll see the concept of character constants, rules for constructing them, and how to define them in C. Thank you.